The rules are there. You take one of your equations, solve for t. You substitute it into the second equation. And then you should simplify into, when they say into rectangular form, it should be something that everyone else can recognize. Or back into a y equals that you could type into your calculator. So that's kind of my rule. This should end up being some sort of y equals or something that you can say that is the standard form. Because you want to be able to type it into your calculator or like, you know, with an ellipse, show the elliptical form equal to 1 or something. All right, so which of these two equations, x or y, would be easiest to solve for t? Let's solve that one for t. And all you have to do is flip-flop it. T is equal to x. What they want you to do then is make that substitution, put it in there, and so my final equation is 1/2, and instead of t, we're replacing it with the x. Now, is that a recognizable rectangular equation? How do you know? What would you say? What is it? What is it? It is linear. What else do you know?
Start at 0.
Positive 1/2 slope. What's my intercept? 0. So for every 1 I go up, I go to the right 2. Up 1 over 2. So that would be my rectangular graph. I can visualize this graph in my head. So now let's go back into parametric mode. We're going to type those two in. I have t and 1/2 or 0.5 t. And I have a pretty slow graph going here. But is it matching it? And you could extend this to be like -10 to 10. And I would switch this to maybe 0.1 to speed things up. Now you can get it to go all the way across the graph. But the point was, parametric, they asked us to graph parametric. It went like this, and it went left to right. So we were supposed to eliminate the parameter, also sketch the graph with indicated direction. So I simplified it into something that we are used to or we are able to work with. This one's a little bit different. It's a trig function, but it's still parametric mode. Okay? So we're going to eliminate the parameter. And to do this, I want you to isolate the trig function. So the first one, I would write cosine of theta is equal to x. And that second one would be sine of theta equals y over 3. Now, you might want, you might have the sign on the right-hand side, but I'm just flip-flopping it. So you isolate the trig function. Does anybody know an equation that would use sine and cosine in one equation?
Tangent equals
Okay, tangent or cotangent, but you just introduced tangent, cotangent. Another one that uses sine and cosine in the same equation. What? What's your equation though?
Just 1.
Right. I guess let's do this. Cosine squared of x plus sine squared of x equals 1. The number one Pythagorean identity uses sine and cosine in the same equation. Because we have isolated our trig functions, I can just substitute now. Instead of writing cosine squared, what can I write? This x can be plugged in here. So it's, maybe I should have made these, I don't know, let's make them like beta so you don't get confused. Doesn't really matter. I'm not substituting this x in for this x or anything, so that's why I want to make sure we're clear. This ends up being x squared. When I do my sign over here, the y over 3 replaces it. So this would be y over 3 squared is equal to 1. So what we're really looking at is x squared over 1 plus y squared over 9 is equal to 1. Do you recognize that as the ellipse that we're working on for 10.1, 10.3? What do you know about this ellipse? Where's its center? Has a center at 0, 0. What are you going to do? Stretch 1 to the right, 1 to the left, up and down 3. So if that's the center, we'll go 1 to the right, 1 to the left, 1, 2, 3, 1, 2, 3. We should, in our heads, already know that that's what the graph looks like. Because we're switching out of parametric, which is difficult to recognize, into rectangular that we do recognize. The last thing would be to go to the calculator and get the direction. So my first equation. Now here's where students get confused once we go to the trig. You cannot force the calculator into a different variable. So you have to ask yourself, what mode am I in? They gave me a parametric equation. So on the calculator, it is still a t variable. So it's sine of the parametric variable. I can't do anything. I'm in parametric mode. Leave it t. Do not worry about that. The second equation was 3. Did I just mess that up? Was it cosine first?
It's cosine.
All right. Sorry. Cosine there. And this one was 3 sine of t, or sine of your variable in parametric mode. Now when you go to your window, what would make sense for your t? Like what number should we plug in? If we're doing a trig equation.
Right.
0 to 10? Negative 10 to 10?
Infinity.
0 to 360 or 0 to 2 pi?
Ooh.
So let's just go back and look at the beginning.
I don't care.
My calculator is in radian mode. I think for most of you, it might be easier to get into degree mode. And then we can tell the calculator goes 0 to 360 by about 10 degrees. Why 0 to 360? That's once around the unit circle, right? Okay, let's take a look. Now, did you see which direction it went?
Yeah.
If not, you can switch.
Next.
So it's going up and around this way.
Counterclockwise or clockwise.
That's the direction. Good. That's where I stop. You could go online and look at the quarterback problem, but we don't do that. So, is there one underneath?
Yeah.
Oh, sorry. There we go. Sorry. Now we're going the other direction. We're going the other direction. So, take this equation. You already recognize x squared plus 1. Tell me what the graph is. Parabola? Parabola. Opening up. Shifted up 1. So you should already have a mental image of a graph doing that. That's what you think of when somebody talks about rectangular mode. We're talking about y equals equations or things that we've been doing up until now. Now they give us a t variable and they're asking us to put it into parametric mode. So what do you need for parametric mode? An x and a y equation. So all we have to do is take this one right here and flip it, and there's my x equation. X is t. If t is equal to x, I can just plug it in right there, and what's your y equation going to be? T squared plus 1. So let's go back to our calculator. Clear that out. I had x is equal to t, and this one is t squared plus 1, right? And the window, now I'm going to go back to a negative 10 to 10 window. And I don't care in this case, but it matches, right? We already have the mental image of a U-shaped graph shifted up 1, and there it is. We can do the same thing here. How do you get x by itself? What would you have to do? Add 2 to the other side, so this would be t plus 2. Or if I take and plug it in there, y is equal to what?
T plus 2 is 5.
So it really is taking this right here, the t plus 2, and you can just put it in there. T plus 2 squared plus 1, right? I'm okay if you leave it like that. You could FOIL it out, and we're just going to verify t plus 1. And then we ended up with t plus 1.
Is it
Two.
on top and in the bottom?
T plus 2.
No, not that one.
Yeah, that was T plus 1.
That one is?
Oh, yeah.
T plus 2. T plus 2 plus 1, yeah. So the first one needs to be t plus 2, and we'll clear this out. And this is t plus 2 square it plus 1. Now it should be a U-shaped graph, shifted up 1. And it is, so we're good.
And I don't know if